Alright, so what use would this active physics system be if we couldn't create some scriptable inputs to it, right? So what we're going to do here is show you how to use forces. So in scripting, we can add forces to just about any rigid body parameter we want. We can change some of these parameters inside the code so we can start creating dynamic movement with objects and control some aspects of the movement with the characters. Okay, so what first thing I'm going to do here is let's just create a new script, right? I'm going to show you how to do it clean without any other stuff. I've got a script on this character here, this player character, and it's called Z Physics Move. And you know all these files are going to be available here inside of this example scripts directory. So all the scripts that I do here are available in the course materials, and you can look over them and see how I did everything. I tried to leave comments on all my code and make everything fairly clear. So what I'm going to do here is let's just create a new one. And let's create a C# script. I'm going to call this Z add force. All right, just so we know exactly what it is. Now I'm going to attach it to one of my cubes. This one does not have a rigid body, therefore I cannot add a force to it. Let's attach it to this cube here. So I'm just going to grab in this Z add force. Boom. All right. So let's go ahead and double click here. Okay. In order to add a force, we must have a rigid body. Now, how do we get that rigid body into our script? Well, we have to create a variable that is a rigid body. So I'm going to say rigid body RB. And we don't really have to have, we can't assign it a value because it's a game component until we use our initialization. And then we can say RB equals this dot game object. Now I'm going to use something new. We haven't used it. Get component, right? I'm going to create a variable out of whatever I've attached this to, and I'm going to grab its rigid body. And I'll work this script down for you in just a minute. All right, so this line of code here is saying, okay, this dot game object, whatever game object this script is attached to, dot get component means somewhere in this object has a component, and these less than and greater than signs, this is an area in which you put the type of object or the type of component you're looking for. And I'm looking for a rigid body. And then these parentheses here, they indicate that this actual get component, it is a method. So we're getting a component, and this is the type, rigid body, and these parentheses mean it's a method. Okay, so that means that what I'm doing here is I'm saying, hey, whatever I decide RB is, it's coming from this object. Now I could also just drag and drop it. I could say public rigid body, and I could drag and drop the rigid body from the editor. It just seems to take so long to do that. And a lot of times you start dragging and dropping and making connections from the scene objects. It gets fairly confusing, and you have to manage all this. It's a lot nicer sometimes when writing a script to automatically assign these Unity type components and game variables from an initialization, like right here under RB equals this. Now, like I said, it wouldn't matter if we commented that out and dragged an object into the editor. It would work just the same. It would just be doing this kind of thing in the editor. All right, so now what I want to do is we're going to add that force, right? Now, when we add a force, generally speaking, we want to add that force based on an input. We can also make it based on an event. We can do all kinds of stuff. But for this, I'm just going to show you how to add a physics force based on an input. So what I'm going to say is if, and we've done this code before, input.get button. And let's just say, actually, let's say get key. We're going to do something a little bit different. This is direct hardware reference, so I'm not using the virtual input manager anymore. I'm just saying get key, and I'm just going to say get key G. Right, so that's the key we're looking for, and that's just a keyboard key press. So now what I'm going to do here is I'm going to say, okay, if this key is being held down, what's going to happen? Well, I'm going to say RB, which is my variable that has the rigid body information in it. And then I'm going to hit dot, and look at all this stuff that pops up. All kinds of stuff. So basically we have mass. We can change anything about this rigid body that we want when a key is pressed. So based on this input, I can do anything I want. The two things we're going to look at is add force and add relative force. All right, adding force is a world space force, right? So I can add force in any world direction. And add relative force adds it in the object's direction. And this is really useful when we have an object that's moving and we want it to move forward. So we want to add force in its forward vector, like a character, if we're moving him forward based on physics. Like, let's say we have a car and I want to move that car forward, but then the car turns and suddenly the forward vector of the car is different than the z-axis of the world. So this relative is really useful to work with local space. Well, let's just click on add force to make things simple. All right, so add force, it is a method, and that method requires an argument. And an argument is a parameter that we're going to feed into this function or method. So right now I create a parentheses and it's saying, all right, where's the force going to be, right? I've got a global force and it's saying on what vector is that force going to be and what's the amount of the force. So I'm going to say 0, 0, 0 for a second here. Okay, that's not going to add any force at all, right? So let's choose, let's get rid of that comma. Let's choose to give it a force of 12 in the z. That means it's going to move forward. I've got a push happening. And a force is a lot like a push, right? It's like giving something a shove. Now, because this is an input, I'm not just giving it a little bit of a shove. I'm going to continuously give it a shove of 12, a value of 12. So if you want to give it a one-time shove, right, then somewhere else, then we would actually say input key down would be a one-time deal. So the second the key is down, we give it a shove. Now if I have get key and I'm holding the key down, then it's going to continuously add that. And if I actually just press it down once, it should be the same as get key down. So let's compile that. And now, let's see here. Add force, I'm going to drop that onto our cube here. And you can see here it is. Now you notice, oops, actually I already had that on there. All right, you notice this RB says none. We created a public variable out of it, and I could very well drop the object that it's attached to onto it, but we've got that little piece of code in there, and let's just look at it again. That does that for me. It just says, hey, whatever object this is attached to, that's the rigid body I'm getting. Now the difference between that and dragging this into that script is that now it's hard locked to that object. So I can't drag that script onto something else and it doesn't get the script, the rigid body that the script is attached to. So let's just say none. And you'll see here when I hit start, it'll pop right into that. Looks like my lighting. I changed a couple parameters on my lighting, so let me just turn that back here. All right, I'm going to hit play and boom. All right, so we've got stuff happening in our physics engine, and you notice how this loaded up automatically. That was that line of code that I had there. It said, hey, load this component up based on whatever object I'm attached to. And now, right, remember what that key was? It was G. Look at that. Boom. Let's start that over. All right, so my physics sim has started. Now I'm going to hit G. G is going to add the amount of force to the z-axis of the object, and that's this cube right here. So if I hit G once, oops, we're going to have to go back to this side and hit it. It applies the force as long as I have the G key held down. So if I keep the G key held down, it's going to keep applying that force. And you see what happens. Let's try that one more time. All right, so hit the G key just a little bit and tap it, and it's going to add that force, but it stops adding the force because update's only getting it if the key is on or pressed. But then if I hold it down, now it's going to continuously add that force to the object for every input, for every update session that comes up, or every update that happens, increment, which is usually 60 times a second, it's going to keep adding a force of 12 in that direction. Turn that off. Right, and so that's a real simple way to add a force. And all of the rest of the forces are very similar to that. Let's go over here. So I can add force here. If I add a relative force, it just says I'm going to add the force in the object's relative local space as opposed to the global world space. And there are a couple other ones here. We have rb.add explosive force. And what does an explosive force do? Well, it creates an outward explosion. We're not going to get into that too much, just because explosions require a little bit more time to set up, but you can create an explosive force and blow up a bunch of objects. So I've done that multiple times. Let's add a torque here. And we're going to add a relative torque because when an object starts to move around and spin, we want the spin to happen consistently in one direction. So a torque, unlike a force, is a spinning action. Right? So we're going to add that relative torque. Now this vector 3 is going to be its period of rotation, right? So we're going to say 0, 0, 0 just to start it out. And then we're going to go over here and say select our object here, and let's have it rotate. And of course this is a cube, so it's going to be interesting to see if this thing rotates and bounces off the ground. We're going to do it in the x-axis, the local x-axis. So let's just say 12 here. And I'm going to hit G. There we go. Now it'll spin. Look at that. Kind of like a square wheel, huh? Jumps right over that object and then goes flying off into space. And you can see the gravity pulls it back down. If I just hit that G a little bit, gravity pulls it back down. And here's a good instance of, because it flipped up, now it's rotating around its x-axis. But because it's the relative x-axis, let's play that again, it's not rotating. I just cause it to flip. And that's because the cube hit the ground odd. Maybe it's not going to happen again. And here's one of the fun things about physics is it's different every time, which is awesome for a game because when you play a game, you want stuff to change a little bit, right? Some games are made to be absolutely pattern-based, and that's awesome, but some games you want stuff to change every time you play it. And the cool thing about physics is it's so variable because it changes so much based on the conditions, based on what's happening, based on the player input. The subtleties can be really interesting and make the gameplay a lot more compelling because it's never the same twice. Right, so this is just a little bit of a rundown on how do we create a force, right? How do we control the creation of that force? And what we did here in the script is that I added a force based on an input. And you can also add a force based on any other parameter or collision or whatever you want. But I just did it based on an input because it's a really easy way to see how you can create controls over forces in the game based on the user input. So it's a really great way to start learning how to script out physics controls for your characters, for your objects, and possibly for all the enemies or environmental objects and elements inside of your game.